Okay, so now we're looking at, again, just continuing on from where we left off in part one. In this part, so we are looking at how to use trigonometric identities to find unknown angles of right triangles. So just get a pencil, and of course I'm always forgetting these. So there is the right angle, so we are labeling. Here is the hypotenuse, it is opposite the 90-degree angle, and it's also the longest length. Here is our unknown angle, so what is opposite that is this one here, that's 82 centimeters, so that's O, and then the adjacent is the other one. Okay, so first of all we can see that we have different units. We have 7 meters and 82 centimeters, so we're going to need to change one of them so that we have the same units. Okay, so just looking at the 7 meter one, so there is 100 centimeters per meter, so in 7 meters there's going to be 700 centimeters. Pardon me. So now they're in the same units. Okay, so we need to figure out what formula, what trigonometric identity we're going to use. Now we have O and we have A. So thinking about SOHCAHTOA, TOA, we want to have TOA, tan. So tan theta equals O over A. So now we put in the information that we've got. We have tan, our theta, well we don't know what theta is, so that stays like that, equals O, which is 82, over A, which is 700. Okay, so now when we want to find what theta is, what we need to do is do the inverse of tan of theta. So similar to the inverse of multiplication is division, the inverse of addition is subtraction. The inverse of tan theta is the inverse function. So what you write is tan -1, so that's the inverse, that -1. Now instead of being theta, what we do is we put in the fraction that's on the other side, so it's 82 divided by 700, and then that's going to equal the value of theta depending on what that is. Okay, so the proof of this is beyond what you need to know in Year 9, and it may be something that you will get into later on, but at this particular time you just need to remember the step of going from here to here. Okay, so let's figure out now what theta is. So just getting the calculator here. It's a bit slow in its movement. Okay, so we go shift, tan, and then we have 82 divided by 700 equals, and it's 6.7 because it does ask to one decimal place, so 6.7 degrees, and that is our value for theta. Okay, so let's look at the next example here. Not sure why that one's in there. Okay, given the following right angle triangle, find theta, phi, and x to one decimal place. So now we have two unknown angles and we also have an unknown side. Okay, so first I'm going to just do the angles. So what I need to know now is, what I'm going to do is I'm just going to circle the angle that I'm going to deal with first. So this is the angle I'm dealing with first. So with that angle, I'm then going to label the triangle. So the opposite to that angle here is O. This is H, apologies again, I need to have that in there, and this is A. So for theta, I have A and I have H. So SOHCAHTOA, so I'm going to use cos. So it's C cos of theta equals A over H. So I have cos of theta equals A, which is 6.7 because they're both in millimeters, over H, which is 10. So then I'm going to have cos to the negative 1 of 6.7 over 10 is going to equal theta. So theta equals, we have again, now we have second function cos, open bracket, 6.7 divided by 10 equals 47.9. So it's 47.9 degrees. So that's our value then for theta. Now when we look at for phi, if we go to the next page, okay, and my x has changed. Where does that x live? Over there. So we ignore this x and put it over here. So now I want to look at this angle phi. So I want to look at what's opposite phi. So now this is opposite. So they actually change. It depends on which angle we're talking about. So now that's opposite. This is still hypotenuse because of this. And now this is adjacent. Okay, so now again, I want to use the measurements that the question's given me so that I don't make any further mistakes. If you have to use information that you've calculated, then you have no other choice and then use that. But if you can avoid it, it's better. Okay, so now I have O and I have H. So now I'm going to use sine. So now I have sine of theta equals O, which is 6.7 over H, which is 10, which is therefore 0.67. Okay, so I do the inverse now. So I have theta equals capital S sine to the negative 1 over 6.7 over 10. And that's going to equal, so I get second function sine, open brackets, 6.7 divided by 10, or I could have just written 0.67, equals 42.1 to one decimal place, equals 42.1. And I didn't check this before, I should have checked, but they're both in millimeters. Phew, so that's good. 42.1 millimeters. Oh, no, it's not. Sorry, it is degrees. Degrees. Okay, cool. Okay, so you may have also realized that we didn't really need to go through all of this to find, oops. Sorry, I've used theta and not phi. I should have used phi. It should be phi. Or phi, and that's phi. Okay, sorry about that. Alright, so this is phi equals 42.1. So you may have noticed that I didn't really need to go through this because I had the other one, so I knew that this was, it was 47.9, right? And I know this is 90, and I know that internally it will add up to 180. So therefore, because I've already got 90, the other two angles are going to add up to 90. Alright, so I could have worked out, because if I would have gone 90 minus 47.9, I'd get 42.1. But I just wanted to show you how to do it using the two different angles and using trigonometric identities. Okay, so now we have one more unknown. We need to find what x is over here. Alright, so we need to find x. So we could use the trigonometric identities because we know two angles now. So we could use one of those and another length to find x. Or to avoid using other calculated information, we can use Pythagoras. So remember, Pythagoras is c squared equals a squared plus b squared. So in this particular case, my C is my hypotenuse, so it's going to be 10 squared equals, and the other ones, it doesn't matter, so we have 6.7 squared plus x squared. So therefore, x is going to equal 10 squared minus 6.7 squared, and the square root of all of that, which is equal to, let's find out. So we have the square root. Where's my square root button here? There it is. Square root, open bracket, of 10 squared, which we know is 100, so I'll just put in 100, minus 6.7 squared, close bracket, equals, and we get 7.4. So we have a length of 7.4. 7.4, and then that's in millimeters. And that's less than the hypotenuse, so that sounds about right. Okay, so that is how to use the trigonometric identity to find lengths and angles in a right triangle.